Okay, so now we're going to go over, now that we've done our decision tree analysis, we are going to go over how we can now take this decision tree analysis and then actually display it. So there's a couple different ways that we can go about doing this, and I want to show you the different ways. First, let me make my two slides, duplicate this. So one way that we can go about displaying this is we can just go back up to we can go back up to this matrix over here, and then we can display that, or we can also just grab our tree and then we can implement our tree over here. Now let's start off with doing the confusion matrix. I am going to recommend that you just take the CSV file that you got, you use that data from the CSV file and make it into a graph in PowerPoint. That shouldn't be too hard for you to do. If you want a reminder of how to do that, you'll just you'll just have to come over here, go to you'll then just download the file. Allow this to download, and then you'll open up your confusion matrix. Give that a second. There we go. Then it's pretty straightforward, all that you need to do. I'll just merge these columns, merge these columns, call this, we want to take this for reference, call this true label, and then predicted label. Okay, we got those two. I think I want to keep these square, so I'm going to do a little trick here. Okay, now that I've increased the font size of that. Also, first, let me make sure everything is size 14. And then Arial, so it matches our branding. Now, for just these cells, I want to make the size, I'll make them, let's try 42. Oh, that's not big enough. Let's try 45. Yeah, that'll work. So I'll make this size 45. Also reformat the text so it goes up this way. And make that center. Or we can play around with that in Excel or in PowerPoint. That'd be easier. Then I can go here, just go down to conventional formatting. Go lowest value is going to be 0, highest value. Okay, let me get my color back here. Why don't we go with, I don't know, we'll go with the blue, or maybe we'll go with the red. Yeah, we'll go with the red theme. Then we'll go ahead and get the hex from that. Come back over here to Excel. Now for highest value color, we just go down here, enter in our hexadecimal, press enter. Okay, there we go. Got what we want. I'm going to bring these back down to size 14. Nope. Let's keep them there. And we can just put this confusion matrix into PowerPoint pretty easy. Two, three, four, five, six. Okay, that looks good. And then we just have to clean this up where we'll just make these size, maybe size 16. That's probably what I should have done, or I guess these are a little bit bigger. Make them size 24. Make everything size 16 initially. And then we can make these size 24. Oh, one thing I should have done before going into PowerPoint was add these borders. That's always easier to do in Excel than PowerPoint. Okay, now let's try this again. One, two, three, four, five, six, 7, 8, 9, 10, 11, 12. Okay, then we'll just make everything size 16. Looks good. We'll make this size 20. Don't want it to be greater than our lead line. This is well size 20. Make sure that's in the center. That should be centered as well. Actually, everything here should be centered, and then wants a float. Yeah, we can have that float. We can edit the text direction. Yeah, that's not too bad. Bring it in a little bit more. That throws off our centering, but we can manually fix that. Make these bold, white, and then fill this with this color. Make this bold, white, fill with that with white, make this one bold, make this one bold, and then we'll make everything in here size 24. Okay, and there we go. We have a confusion matrix. So that's one way how to do it. But I did want to promise you guys, I did want to show you guys how to get into like making it a more custom plot over here. So let's go back. Let's see if we can try to make something similar to this going back into our code. This is all the stuff from ChatGPT. Let me add a new section and just call this section custom graphs. So I can go up here. I'm going to bring this back down. And if I run that, mix of strings. Well, that's interesting. Hmm. Okay, I think this is throwing it off. Let me get the my predict again. Yeah, I might need to rerun this whole thing without that. Yeah, so the other code, the code from ChatGPT was mixing up the variable names so we can reproduce the graph, so I had to rerun everything. But here we go, we have our confusion matrix down here. And before I do anything, what I want to do is I want to enter some new code. And I'm going to enter colors from Matplot. Then I want to make my hex codes. I'll come back to that. Then positions. And I'll come back to that as well. Colors is going to be equal to our list of our map of our M colors. We want to convert the hex to RGBA. And to do that, we will take our hex codes and then we'll make my CMap equal to M colors dot linear segment color map from list, and then we'll call this my CMap colors, and then the number will be equal to 256 because that's how many degrees there are in colors. So if I do, for instance, I'll just pull some random hex that we want. We'll take that hex code. We'll have that as one of the values. And then we'll have our first value. Our reverse value be white, which is just F, 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 F. And then our positions will be 0 and 1. Run that, that runs just fine. Now when we go down here to display, we can add our new CMap. We say CMap equals equals my CMap. Run that. And you see we now get the new colors, and we'll play around with this a little bit more to get the colors where we want it to, but we'll leave it at that for right now. Next thing I want to do, this display is very low resolution, so I'm going to make it a little bit bigger by setting the figure size, and we'll just do it in, figure dot set size inches to 10 to 8. Okay, that gets us a lot bigger, but now our fonts are super small. So I'm going to make this new dictionary, and I'm going to call it font. And I have a family parameter in it. I'm going to have a weight parameter in it. I'm going to have a size parameter in it. I'll just leave it at that for right now. And so, what I can then do is I can go ahead and enter some kind of font family that I want. Now, I don't believe I looked for it. I couldn't figure out how to get it, but I guess if one of you is able to find it, let me know. But I was not able to find Arial for Matplotlib, so I'm just going to revert to sans serif, since Arial is a sans serif font. I want to keep the weight at normal. And then my font size, oh, this is going to need commas in it. And then my font size, I want to be 16. And then I'm going to take our plot and just tell it to reset the fonts. And I want the fonts to use font, or what we set up here. And that might take a couple iterations to run, but you can see now that the font size is 16, much easier to read. I can also do I can change, if I change this to serif, you'll now notice I have a serif font, so if you're using Times New Roman, this can match up a lot better, but I'm going to leave it as sans serif for what my purposes of what I am trying to do. And then maybe we can go ahead and set some more, we can set some more of these in. Actually, I'm not sure if I'm even using the position variable here. We don't need that. So now maybe, for instance, I want to add, maybe differentiate the white colors from the dark colors. Let me go back and find what this blue color is equal to. I'll get the hex code for that, go back to our plot over here. I'm going to add that. So here, this might be good just to label for you guys. Red equals this. White equals this. And then blue equals this. So then we can, that should make our array a lot easier to work with. So I can just say bottom color is going to be white, next color is going to be red, next color is going to be white, next color is going to be blue. And watch how that affects our scale. Okay, let's see, what can we do to make this better? Maybe this is 21, that's 20. Maybe we want to add a light blue color in there as well. Let's get, here we go. This is a little bit lighter color that we can add in. I'm not going to worry about labeling that. Okay, and now we get like this graph that's kind of showing us our errors and what did well and then what didn't do well. And I think that's sufficient for right now. I just want you to notice though how complicated this process can be just to get a plot in Python to look the way you want it to. Like, if you compare like these two, this took barely any time and it's very easy for me to go back and edit, where this plot, it takes a lot of coding and stuff to get done. So if you want to try to play around with getting better at making custom plots like that, go for it. In Python, I just want to show you kind of an introduction of how to get there. I think I'll be sticking with this plot though, just because it looks cleaner, a little bit more smooth, and it just matches our color palette a little better. So I'm going to I then want to get I'm going to make a lead line about this. Just an insight. Let's see that. Okay, our model What was the accuracy of this model? Oh, we've had so many different accuracy scores, it's kind of hard to tell. Okay, we can actually just calculate the accuracy of this right with a calculator really quick. So we got 28 plus 17 plus 25 plus 5. So we got 75 total. So 75 minus 5 equals 70 divided by 75. Accuracy equals 93%. Okay. So our model, I'll add the 93% over there for later. Our model can classify our model. Okay, what about the model? Classified the testing data with 93% accuracy, but has a tendency to mislabel Virginica as versicolor. It has a tendency to mislabel. I don't have the proper F statistics for it, but I'm just going to go back up and grab these. And talk about while precision and recall are perfect for setosis, versicolor and Virginica has metric values range between, what is this? Say 95 and 80% range between 0.8 to 0.95. I'm actually going to look back at some of the exploratory data we did. As you can see, the versicolor and Virginica are both clustered together pretty well. So I'm going to interpret this as this may be due to Virginica and sea color being closely clustered. In terms of their features. And then final recommendation, I'll just say perhaps we should, perhaps it would be beneficial beneficial to collect additional features for the observations that have higher variance between Virginica and versicolor. Maybe something like, I don't know, petal color. That might be an interesting feature to use. Region. Okay. So that's one way I can look at this analysis. We'll move that away for right now. Another thing I can do is I can look at this. I can try to make a decision tree. So going back down here, here's our decision tree that we have. If I want to make a custom plot, unfortunately, this export graph does not have a lot of options. All what I can really do to kind of make it fit in with our graph a little bit more is I'm going to change the fill color to have no fill color and make it more rounded. And then because we're using a lot of sharp edges in our PowerPoint, so it makes sense if we're not as rounded. So we can do something like that. This works, but it's not as, I don't know. I like this. I like how this looks a lot better. But also, if anybody sees this, the first thing that'll come into their head is scikit-learn or a library of scikit-learn. I'm sure there's other graphing libraries to be able to plot out the decision tree. So you might want to take a look at those. Also, does this have a... Okay. Yeah, that is the shorter depth decision tree. Let's use this as a reference. So that's 1, 2, okay, that's 3. That's not too bad. Okay, so the way I would go about recreating this in PowerPoint, I'm not going to use that one. I'll use this for reference. So I'll start off by using some smart art and then customizing it to make it fit my needs better. So I'll start off with using an organizational chart, going to hierarchies in smart art and clicking on org chart. It'll give me something really nice and simple that I can start off with. I'll just get rid of that. First, I'll type up here petal width is greater than 0.8. And then I have my 2 setosa. If it is, then it's setosa. If it's not, then it checks if petal width is greater than 1.75. And if it is, then it'll check petal length is greater than or less than 4.65 versus If not, it will just be classified as Virginica. So let me capitalize these. However, we have this last tree, which, oh, that's interesting. Look at that. It reclassifies it versicolor, versicolor. Okay, we can just stop it at right there. We would need to investigate the model a little bit more. Okay, but that is the basis of our decision tree. Oh, it looks like. So now I'm just going to bring this back to standard, because that's how we want it to look like. We'll make these whiter. Oops. Make these ones smaller. Also, all the text in here, let's bring it to size 16. Maybe that's a little bit too small. Um, let's move this down, that down, and let's move this up. Why don't we align that? Actually, never mind. We'll keep that there. Okay. How do I want to color this? What colors do we have? We got a green, a plum, and a blue. Okay. Yeah, I kind of like that. And then we can add in the text for true, false. It would be interesting too if we did something like, oh no, we'll just leave it. We don't necessarily have to show that. Okay, so now we have our decision tree. I'll still want to take some of the information from here. pedal width is the best feature to classify the data is the best feature to classify the data I guess I could go into more detail than that. Pedal width is the best feature to classify the data, implying that it is an important differentiating feature. It's an important feature on that. It may be the most important feature for analysis. Okay, pedal width is used both to define is used twice in the decision tree at the highest levels to split the data the first time having a Gini value of 0.657 and just and basically just the Gini value is just telling you how much impurity there is in the data. I don't know if I want to include that actually. That can get complicated to explain. It should be noted that the model is unsure of its predictions with versicolor especially when pedal length is greater. Model becomes more unsure of its predictions with versicolor when the pedal length is greater than 4.65. Model with its classification of the versicolor species. That's something that this graph doesn't necessarily show. If the pedal width is greater than 0.8, there is high certainty that the species is Setosa. We can look back at our pair plot here, look at petal width. Let's see, what were we saying here? Petal width is used, I'm sorry, it's not greater, it's less than 0.8. Okay, so let's look at petal, what is it, petal width? That's sepal width, petal width. Yeah, look at that. Yeah, if we zoom in on this pair plot that we did a while ago, you noticed. Basically, yeah, if petal width is less than 0.8, we can be sure that it is Setosa. So it's good to spot check those things. Oh, and there is nearly there is a very high. What can I pull from this? Let's see, best graph, metric score. Did we do this analysis? I want to run it one more time. This time on best. On that. I'll just say with 100%. There's 100%. With 100% precision. Okay, there we go. Okay, those are our two models. See source source iris data. If you want to add more footnotes about statistical significance or anything, down here would be the place to do it. But that wraps up these slides. I hope that this was helpful for all of you.